Welcome to the video, finishing up scientific notation, second section in our algebra skills introduction. Scientific notation, hopefully you're aware of from previous classes, but what's scientific notation used for? Used for writing really small numbers or really large numbers. So a lot of uses in the sciences, whether you're talking about cells or atoms or possibly planets and distances between stars even. But also in things like economics, history class, expressing larger, smaller numbers. So what are our rules for scientific notation? Well, this first number, this is our generic setup. This first number always has to be between the numbers 1 and 10. And we use this times 10 to the, because when we multiply by 10, we can easily think of it as just moving a decimal point either to the right or left. And this number, kind of shorthand, you can think of it as telling us, is our number getting larger or is it getting smaller? Do we have a decimal number? Do we have a very large number? So let's see how this operates, how we can interpret our scientific notation. So if I had a number like 6.4 times 10 to the 5th, positive exponents means move to the right. And for 2.17, move that decimal place. Negative exponents mean move to the left. So negative numbers, we're getting a smaller number as a result. Positive numbers are getting larger. So if I write out 6.4, this times 10 to the 5th, if you think about multiplying by 10, your shortcut is move the decimal place over to the right. So we're going to move over to the right 1, 2, 3, 4, 5 times. Any blank spaces, so there's where our decimal ends up. Any blank spaces would be fill it in with a 0. So 640,000. Another way to express 640,000. If we want to express a smaller number, 2.17, 10 to the negative third means move that. Basically, you're dividing by 10 every time. You're going to move that decimal place to the left 3 times. And blank spaces get filled in with zeros. So this is 0.00217. Make sure you count those zeros carefully. If we're going to write a number as scientific notation, if the decimal point's not written in there, we know it's at the end of the number, and you're going to place it wherever in the number you could place it and make a number between 1 and 10. You have to remember that fact. We're looking for a number between 1 and 10. So where we're going to put it, we're going to put it at 3.2. So our number becomes 3.2, and you don't need to write all these trailing zeros because 3.2 is the same as if I wrote 3.2000. Doesn't matter how many zeros I write after it, we're saying that's still the same number. You may see different things in chemistry with significant figures and the like, but we're only going with the basics for scientific notation. So 3.2 times 10 to the, our basic setup, and then we need to figure out the exponent. So how many times did we move? We moved 8 times from our original position for the decimal. So 3.2 times 10 to the 8th, and this is a positive number because this number got bigger. If I compare 3.2 to 320 million, 320 million is larger. We're going to move that decimal place point to the right when we're making 3.2 into 320 million. So that's going to be a positive number. On the other hand, if we look at our example at the bottom, we're going to make that a number between 1 and 10. We need to make that 5.239, write as many decimals as you can that are not, that is as long as you don't have a discontinuation of zeros, times 10 to the, and this is going to be a negative exponent because I have a smaller number. We had to make 5.239 smaller to get back to our original number, so we moved 1, 2, 3, 4, 5, 10 to the negative 5th. To practice, here are two for you to attempt. More kind of realistic numbers that you may see inside the sciences, economics, that sort of thing. So go ahead and try these. How many zeros do we have just to help you out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 before the 8. Your calculator can be a useful tool for scientific notation. So just so you guys can see, if you were going to write, say 2.72 times 10 to the 5th. If you wanted to type that into your calculator, if you wanted to see what number that was, two options you actually do have if you use the mode button on your calculator. So if you use the mode button, you'll see SCI under your first menu there. You could select that, and this would be scientific notation. Every answer you would put in, everything you type in, if any calculator's giving you a number, it's going to give you the answer in scientific notation. So that's one place where we see scientific notation on your calculator. If you press enter, just realize you would need to switch that back if you didn't want scientific notation. The other thing is your calculator can put in a number like 2.72 times 10 to the 5th pretty easily. If you type in 2.72 and then right above the comma, if you press the second and then it's the comma, but really what you're looking at is the EE, and then type in 5 and press enter, you've just put that number into your calculator. EE, which I've read stands for engineering exponent, not important to you. It means times 10 to the, and then you put in the power. So it's allowing you to type in scientific notation into your calculator, which can be a useful shortcut. If we're going to do computations with scientific notation, we need to think about some of the properties we have for exponents and numbers in general. If we're going to do this problem short of just typing it straight into your calculator, you can use properties that we use every day. So if you notice this is a multiplication problem, all we have is basically we can treat these as 4 different numbers being multiplied. So what would be easiest to multiply? Well, it'd be easiest to multiply the 6.1 and the 4, and then 10 to the 5th with 10 to the negative 9th. If you remember what we did on Friday, our exponent rules, same base, multiplication, means we are going to add those exponents together. So those 10 to the 5 plus negative 9 equals negative 4. We're going to put times 10 to the negative 4th. And if we have 6.1 times 4, that would be 24.4. So 24.4 is not in scientific notation. We need to move that decimal place 1 to the left. So that means we're going to add 1. If you remember, we have 2.44. If we're trying to say that 24.4 is bigger, we're going to go to a positive number. We're going to add 1 on to that. So 2.44, you want your answer left in scientific notation. So we have multiplication rules. We also have division rules. So if we remember our division rules, we're going to put this in scientific notation. 10 to the 4th divided by 10 to the negative 2nd. Remember, we subtract those exponents. So that would be 10 to the 6th power. So times 10 to the 6th, and if we have 1.8 divided by 3, if you have 1.8 divided by 3, it's actually going to be the decimal 0.6. So I have 0.6 times 10 to the 6th. I need to move that decimal place over in order to make this scientific notation. So 6 times 10 to the, and I have a smaller number that I turned into scientific notation, so I'm going to subtract 1. We're going more negative. So 6 times 10 to the 5th would be your final answer on that problem. Here's a challenge that I'm going to leave you with. Just remember, for scientific notation, we're going to combine like exponents that when they have the same base. So my hint to you is change these into scientific notation first, then go step by step. So change these into scientific notation. Good luck. Have a good long weekend. See you on Tuesday.